Hello everyone and welcome to lesson 5-2, chapter 5, lesson 2, sequences. This lesson is found on page 357. Well, what is a sequence? A sequence is an ordered list of numbers. Each number in a sequence is called a term. Okay, so we call the numbers terms. In an arithmetic sequence, each term is found by adding the same number to the previous term. So here we have an example of arithmetic sequences. We have, for example, numbers. Continue each sequence. We have 1 to 3, so we've gone up by 2, 3 to 5, 2 more, 5 to 7, 2 more. So it's logical that the next number will go up by 2 more, and it should be 9. Okay? Now we have 1, and we see the difference to 1.5, and then from 1.5 it goes to 2. I can see that it's going up by 0.5 each time. You see that? 0.5. So if it's 2 here, what will be the next number if you add another 0.5? 2.5. And then another 0.5 will make it 3. Plus 0.5, plus decimal 5, 3 decimal 5, and so on. Now let's describe each sequence. Okay, so describe each sequence. The first one we had to add 2 to the previous term. Now let's write our own sentence for the second one, for this one. What do we have to do? Well, we add 0.5 to the previous term. Please write this down, copy this down. Remember, these are all key answers. So put a star there, and let's add 2 more, just to make it look filled with stars. Real world link. Horseback riding. The number of students who went on each horseback riding trip is shown. The numbers represent the terms, okay, of an arithmetic sequence. Explain. Let's see. The trip. First trip. Number of students were 15. On the first trip we have 15 students. On the second trip, 16 students. It went only up by 1. On the third trip, we had 18 students. Compared to the second trip, it went up by 1. Compared to the first trip, it went up by 3. Then on the fourth trip, it went up by another 3 to 21. But then on the fifth trip, it went up by 4. So if I were to write the differences down, we see that from first trip to second trip, it went up by 1. So plus 1. Second trip, plus 2. Third trip, plus 3. Fourth trip, plus 4. Well, you might think this is a pattern, 1, 2, 3, 4. But it's really not. It has to go up by the same term in order for it to be sequential, in order for it to be, I guess, proportional. But it's not. So, is this an arithmetic sequence? No. The same number is not added to the previous term as we agreed earlier. The numbers increase by 1, 2, 3, and 4. So it is not sequential because the same term is not being added. Again, boys and girls, this is another key answer. Describe and extend sequences. Okay, an arithmetic sequence, right? Arithmetic sequence is when it goes up by the same term, right? But I want to make note that the terms can be whole numbers. 1, 2, 3, 4, 5, negative 1, negative 2, negative 3. It can be whole numbers. It can also be fractions, half, a third, and they can also be decimals, 0.5. They can be 1/3, and so on. So make sure that you are able to pick up on the fact that it can also be a fraction of a number. In example 1, you'll notice that they show you a typical question, and then they ask you, continue the pattern to find the next 3 terms, the next 3 numbers, okay, in the next 3 terms. And you see that it's plus 5 each time. So you want to find the next 3 after 23. So you know that it's plus 5, so you should always add plus 5. You have 28, you add plus 5 to that, it's 33. You add plus 5 to that, and you get 38. So these 3 right here would be your next 3 terms. In example 2, you'll be asked to continue to find the next 3 terms, but look at the pattern this time. We're only going up by decimal 2, so 2/10. You see that? Decimal 2, decimal 2, decimal 2. So we continue that, we just continue to add decimal 2 to the next term. So we're looking for the next 3 after 1. So it would be 1.2 plus another 0.2, 1.4 plus another 0.2, 1.6. Okay, I think we're ready to practice. I think, boys and girls, I'm quite convinced that you can do this on your own. A, B, C, D. So right now, please pause the video, pause it now, and try it on your own. Okay, go ahead and pause. Okay, I hope you paused the video and now we're ready to check. I've noticed just by doing a little observation that here it goes up by 13. And again, if I add 13, I get 26. If I add 13, I get 39. So the rule is plus 13. Okay, over here, term by term, it seems to be going up by 3 each time. So the rule is plus 3. And over here we have decimal 3. See, that's we have 1, and it goes up to 1 decimal 3, 1 decimal 6, 1 decimal 9. So it seems to be going up. The rule is 0 decimal 3. And over here it seems to be going up by decimal 5 each time. Decimal 5, or 0.5. And so, or a half, you could even call this. So it goes up by a half each time. Now we're being asked to find the next 3 terms for each one. So for number 1, I took my 39 and I added the 13 and I got 52. That's my first term, okay, out of the 3 that I'm being asked to find. Then I took my 52 and I added another 13, I get 65. And I took my 65 and I added another 13, I got 78. So here are my next 3 terms. You can go ahead and copy these 3 down in order, separated by a comma right in there, okay. And for B, as we mentioned, the rule is plus 3. So I took my 13, my last term, and I added 3, I got 16. Then to 16, I added another 3, I got 19. And then to my 19, I added another 3, and I got 22. And there are my next 3 terms. Again, you can copy those right there. Okay, now C, we notice that our rule was plus decimal 3. So I take my last term, 1.9 plus decimal 3 is 2.2. Take my 2.2, add another decimal 3, and I get 2 decimal 5. Take my 2 decimal 5, add another decimal 3, and I get 2 decimal 8. And there are my next 3 terms. Go ahead and have those copied. I hope you're getting all of these correct. I really do hope you paused the video and that you're getting them all correct. And lastly, our rule was adding decimal 5. So we take our last term, 4, and we add decimal 5, we get 4 decimal 5. We take 4 decimal 5, add decimal 5, and we get 5. Take our 5, add decimal 5, and we get 5 decimal 5. And there it is, boys and girls. In algebraic sequences or expressions, we often refer to first position, second position, third position when we are identifying terms as they're increasing. And yes, when we have the sequence 2, 4, 6, 8, as we have right there, our first position, the first term, is 2. Then our second position, when we move to our second term, is 4. Third position is 6, and fourth position. All we're trying to express here is that we define these positions as first, second, third, fourth, and so on. Okay? What I should clarify is that we don't say 1, 2, 3, 4. No, we say first, second, third, fourth. Got it? Since we're able to identify the rule is always goes up by 2, okay, we can actually take our first position, second position, and so on, and use it in our operation. You see, first position times 2 is 2. Second position times 2 is 3. Third position times 2 is 6. And fourth position times 2 is 8. And it actually gives us the value of the terms. If we don't know what position we're looking for, you can also use an algebraic expression to represent the relationship between the term and the sequence of its position in the sequence. In this case, if n represents the position, okay, because we don't know what position we're looking for, the value of the term is 2 because we know the rule. We know that the rule is going up by 2, right? Each time, 2, 4, 6, 8, and so on, right? We know the rule goes up by 2, but we don't know what position we're looking for. So we just say 2n. If it's, let's say it's position 12, just to give a position. It's position 12, so n equals 12. We're looking for that position. We would have 2 times 12, and our number on the sequence, our term, would be 24, right? For example 3, we have the same concept of terms and position and so on. So please go ahead, take a look at it so you can see this context and how it is used, how n is replaced with 100. Please go ahead, take your own time to look at this. If you don't understand it, ask me in class. Okay, let's try this one together. If the pattern continues, what algebraic expression can be used to find the number of circles used in any figure? How many circles will be in the 50th figure? So this is what they're asking us. They're asking us for the 50th position. So here's figure 1, or position 1. It's 3. Figure 2 goes up by another 3. See that? You have 6. In figure 3 we have 3, 6, 9. So our rule is, looks like it's going up by 3 each time, plus 3, right? If it's plus 3, then we can write it as 3 times the position, right? The position. that we're looking for. Not the first, not the second, or the third, but it's 50, and we know that. So we can say it's going to be 3 each time, all the way up to 50. So 3 times 50, and that equals 150. So there will be 150 of these little circles when we get to position to figure 50. Does that make sense? Okay, I hope you can copy this down exactly as I have it copied down right here as a key answer. It's a guided practice. Please leave it for class. And in the independent practice, I actually want to do 1 or 2 questions with you as a key answer to make sure that you're actually watching this entire video. I will do 9 with you, which is on page 362, the back of the independent page. Kendra is stacking boxes of tissues for a store display. She stacks 3 boxes in the first minute, 6 boxes at the end of the second minute, and 9 boxes by the end of the third minute. Suppose the pattern continues for parts A to D. So we have A to D. And it looks like every minute she's doing 3. That seems to be our rule. I have my table here, okay, and I'm going to assign a variable x. I'm going to assign it the number of minutes. So I have 1 minute, 2 minutes, 3, 4, and 5 minutes, okay? And I'm going to use y. Okay, y is going to be the number of boxes stacked. And we know that in the first minute is 3. In the second minute is 6. The third minute is 9. The fourth minute would be, if we continue with this pattern of plus 3, will be 12. And by the fifth minute, she will have stacked 15 boxes. B. Write an expression to find the nth term in the sequence. Well, we don't know what nth term is. It could be any term, but we do know that the rule is that it's always going to be 3 per minute. So 3 times n, or you can simply write it as 3n, right? Because it doesn't matter how many minutes, we can always replace n with the number of minutes, and we multiply it by 3 because each minute is 3. Okay, now we're going to look at graphing. Graph the table of values from part A on the coordinate plane. The coordinate plane right here, boys and girls. Okay, the coordinate plane. We're going to graph this table that we have up here, right there, using x and y. Let x represent the number of minutes, which I did, and y represent the number of boxes. We did that, right? Right in the bottom there. Then describe the graph. Since we already know the rule, I don't have to look at the graph or at the table while I do this. So what I'm going to do is I'm going to go right ahead and graph it. And I know that along the bottom I have the number of minutes. So in my first minute, how many boxes do I have? I have between 2 and 4, so I have 3 right there. I can't really see that, so we'll make it bigger. And then in the second minute, okay, I have 6 boxes. That one can go right on between the 2 lines. And then in the third minute, and so on. So remember, by every minute I'm going to go up by 3 on my y-axis. Every minute here I'm going to go up by 3. So it looks like this. Okay, every minute we go up by 3. You can see, pause and see what I have there. And you can tell that it's a proportional relationship, very sequential. Every time this goes up by 1, this goes up by 3, and it goes right through the 0. If it goes through the 0, we say it's a proportional relationship. So we know that the number of boxes increases by 3 each minute. The points appear to fall in a straight line passing through the origin. The origin is the 0, 0, okay? The 0, 0 on the y and x-axis. So that's what we call the origin. That makes it a proportional relationship. And finally, D. How many boxes will be displayed after 45 minutes? Each minute is 3. So we're going to write our rule of 3 minutes, times n, right? Or we can just simply write it 3n. I just like to show that this is a multiplication. But it's 3n, we can write it. And when I replace the variable, okay, I'm going to have 3 for every 45. Okay, 3 for every minute in 45. And when I multiply those two, I get 135. So how many boxes will be displayed after 45 minutes? 135 boxes. Alright, boys and girls, I'll see you in class.